Hi, Chris.
Good morning, Sally. How are you?
Hi. Nice to see you on. Great. We'll give folks another minute or so to join, and then we will get started. Let's go ahead and get started. Good
Good
afternoon
afternoon.
to our esteemed colleagues from Israel, and good morning to our EPA staff. Again, my name is Sally Gutierrez from USEPA's Office of Research and Development. Today's presentation is on the National Pollutant Discharge Elimination System, which is the nation's wastewater permitting system. In terms of meeting logistics, the recording for the presentation has already started, and the recording, at least for the first one, I'm not sure about the second one, Phyllis. Is the second one up now? Both of the recordings are now available on the Posey Global website. Please feel free to write your questions in English in the chat box. And should you have any questions in Hebrew, please send them to the email or WhatsApp number listed in the chat. And if there's any problem with seeing that information, please let me know. Just pose a question there in the chat for me, because I understand that some folks could not see it last time. We ask that you please mute your microphones unless you are speaking, to keep the webinar on track. And with that, as just a little bit on logistics, I want to invite Mr. Christopher Kloss, who is the Director of the Water Permits Division in the Office of Wastewater Management, Office of Water, US EPA, to provide opening remarks. And Chris has the distinct honor, I guess, Chris, of leading the NPDES program for the country. And he is a very capable engineer, very, very experienced. And I wanted him to provide just some introductory remarks. Thank you. Over to you, Chris.
Thanks very much, Sally, and hello to everyone. I first wanted to thank everybody from the Israel Ministry of Environmental Protection and the Ministry of Health for joining us today. As Sally mentioned, I'm just going to have a few moments of remarks before I turn it over to Sean and Kevin to really dive into the bulk of the discussion. But I did just want to thank Sally and Phyllis Posey for having us here and organizing this webinar series, and for this collaborative discussion that I know that we're the third part of this, and I think it's a great opportunity for us to dialogue on this. So as Sally mentioned, I work in our water permits division, and we oversee our wastewater permitting program here in the U.S. It is the largest environmental permitting program that we have in the country. We do have that distinction. And we have about 750,000 permittees all across the country. One of the things that's unique about our federal program is that all but 3 of our 50 states actually write the permits for the program. So we play a dual role of writing some permits, but also providing an oversight role to the states that write the permits on behalf of the federal program. So it is a very interesting system, a lot of complexities when we roll out national policy, and all the states add their own flavor to how they implement the program on behalf of the federal government. So there's a lot of nuance to it that I'm sure Sean and Kevin will get into some of those details as we go forward with today's discussion. And then as part of that as well, we permit everything that is basically a facility discharge, and everything from rainwater all the way to treatment plants to industrial facilities, and actually even the application of pesticides that hit waters here in the United States. So it is a very diverse program that has a lot of legal challenges, a lot of technical issues for us to unpack. So we have a wide range in our program of lawyers, scientists, engineers that work in collaboration, not only here where we have a staff of about 40, but across our regional offices and in coordination with our state programs as well. And then this is also an interesting week to be talking to you as well, just because the bipartisan infrastructure law was signed earlier this week on Monday. And this will provide $50 billion plus for water infrastructure. About half of that, as Sally mentioned, we do the wastewater permitting. About half of that is going to the public wastewater side of the house. As may come up in the discussion today, a lot of our permittees on the municipal side that are doing sewage treatment are very resource constrained. And so we look at this over the next 5 years as not only a great opportunity to invest, but also make tremendous progress in the permitting program as well, and how we complement that. So with that, I just want to say thanks again for having us today. We're really excited to be here. And excited to engage in this, bilateral dialogue. And I think I'll turn it over to Sean and say, he'll have a lot of great things to provide for you. So thanks again.
Thank you, Chris. And now I'd like to introduce our speakers. So we'll have two senior staff today. Sean Ramesh is the permit writer training coordinator for the National Pollutant Discharge Elimination System program. He is part of the national program branch in the Water Permits Division. He has a great deal of experience developing training and is really a technical, really a national technical expert on many things in PDES. Sean has a BS in biology from Duke University and a Master's of Environmental Management from Duke University Nicholas School of the Environment. In addition to Sean, we'll have Kevin Wise, who is the branch chief of the National Program Branch, and he is responsible for one of the units that is overseeing the states as they administer their programs. So Mr. Weiss has an MS in chemical engineering from Carnegie Mellon University and a JD from George Washington University. So with that, I'm going to invite Sean to do your thing.
All right. Well, thank you, Sally. And thanks everybody for being here. Gonna get my screen shared here. Give me just a second to get set back up. I luckily have multiple screens at home so I can see you guys while I'm presenting to you at the same time. Sally, can you see the presentation now? Yep, good. All right.
Yes.
So this is, a real challenge. As Chris mentioned, this is a very diverse program. The permit writers course that I teach is a week-long course, 5 days of instruction on implementing the basic tenets of the MPDS program. So distilling it down is really a challenge. So did the best I could, but we're going to move through material relatively fast. I will try and talk slow. That's always a challenge when you're trying to get through material, but I recognize there may be, some language barriers, so I'll try and keep it as slow as I can. The previous sessions have covered some of the material, so I do have some slides that we're going to move through a little bit quickly, but it's important, I think, to have this presentation be standalone. So if you're looking back at this, the concepts and the requirements are there. So we do have some slides that I'll move through relatively fast, but I want to give you some highlights from those that are important for the MPDS program. So as with the previous presentations, feel free to raise your hand, ask questions at any time. We'll try and stop and address them to the best extent we can. If it's a more lengthy answer, I may ask that we hold it until the end just so that we can keep getting through the material today. Based on the feedback that I saw we got from some of the previous presentations, I've tried to include a little bit more technical content. And the way I'm going to try and approach it is show some technical material, but I'm really trying to transmit the concept that it embodies. Because as I said, to get into the real technical details, it's a week-long course. How we actually do the statistics, how we actually calculate limits. how EPA develops the requirements is pretty involved. So with that, let me go ahead and move on to the next slide. So what are we going to cover today? So quickly, the regulatory background of the NPDES program, the pre-treatment program, and this is not technically part of the NPDES program, but it's complementary to the program, and it's very akin to the requirements you put on your waste producers. So I did want to provide the chance to talk about it a little bit today, and we do have the staff that are the experts in that program if we do have some questions that come up. How we apply for an NPDES permit. Technology-based effluent limitations. Marielle and Levine covered this to some extent, but I'm going to try and give you a little bit more practical look at it. Water quality-based effluent limitations. Here in the U.S., the NPDES program applies to direct dischargers. So water quality standards are very important because every water has different uses and different requirements. I understand that's not the case necessarily in your country because your water is mostly reused for agricultural uses. So there's not really this discharge just into a free-flowing water body. It's all managed water and controlled. And then how we look at all those effluent limits that we just calculated and pick the final ones that apply to the permittee and the permit. And then monitoring and reporting, and then a little bit about the administrative process, and really, once again, just the concepts there versus the practice. So with that, let's move on to the regulatory background and just talk about that again. So I know Randy covered this, but just remember a very ambitious goal: eliminate the discharge of pollutants to navigable waters by 1985. And the NPDES program, National Pollutant Discharge Elimination System, was the keystone of this effort. So important to remember, though, is that the NPDES program only applies to direct dischargers, so dischargers to navigable waters, and we'll talk about those terms again quickly. And then that interim goal of what we typically call the fishable, swimmable goal. So the idea that we want to stop facilities from discharging into the waters, but there's, even if we get to the complete discharge of pollutants from point sources, we also want to have a goal to have fishable, swimmable waters. And the Act does address non-point sources through different mechanisms in the Act, but not under the NPDES program. So important to remember, the Act was more expansive than just the NPDES program. So all point sources discharging pollutants into waters of the United States must obtain an NPDES permit from EPA or an authorized state, territory, or tribe. And this is a very important point. This determines who is subject to the NPDES permit program, and also very important, that authorized state. The model that Congress chose to implement was that hopefully over time, all of the states would issue NPDES permits and EPA would act in an oversight role. As I'll show on a slide in a little bit, we've gotten fairly far along those to that goal, but not all the way yet. So let's look at the terms here a little bit. So we have point source. So this is that broad definition that Randy showed you. And as Chris mentioned, over time, we've had to expand this definition. One thing that the US is well known for is litigation. EPA gets sued by environmental groups. Industry sues about what we do and what we don't. And courts ultimately interpret the statute, the Clean Water Act, and tell EPA, you need to do this. So over the course of history, we've had new components added. Pesticides was one that was added. Vessels were added. So large ships that discharge wastewater from ships were covered. That actually was recently changed to revert to the Coast Guard, so it's not in the NPDES program anymore, and it's been a big change to how many permits we have covered. But the important point here is that a point source is very broad. It's an interpretation of which sources are subject to the NPDES program. Now, one of the important things was return flows from irrigated agriculture or agricultural stormwater runoff are not considered point sources. And this wasn't because they weren't deemed to be discharging pollutants that were of concern. It was that when the Clean Water Act was being written, there was it was recognized that agricultural in the eastern part of the country, where there's a lot of flowing water, had different requirements for irrigation than the west, which is more of a desert climate, where irrigation was very key to be able to grow crops. And so because of those differences, there would have been a burden on the Western agricultural community that wouldn't be on the Eastern to try and comply with the discharge of pollutants. So at the time, Congress just said, we're not going to make them subject to the NPDES program, but they would still be subject to non-point source programs, is what we call it, under the Clean Water Act, and state by state specific regulations of agricultural discharges. So it's not that they weren't addressed, it's just not addressed under this formal NPDES program, which was really targeted more at the wastewater treatment plants and industrial sources. So classes of pollutants. Not going to look at that definition again specifically. Randy showed you that, but it's a very broad definition. And that's how pesticides were brought in. Pesticides themselves, the product, we don't regulate. That's regulated under a different federal act. But once they're applied, there's an application time, a residence time, and once that passes, there's a chemical waste left. There's a residue, and that's what we regulate. So it's important to note that we regulate waste. We don't regulate products. But when a product is applied and it's past its useful application time, then it becomes a waste, and then it becomes subject to the NPDES program. That's kind of the best way to describe that. But the pollutants are divided into three primary categories under the Clean Water Act. Conventional pollutants, and these are essentially those that you would expect to see from a domestic sewage treatment plant. Toxic pollutants. Now, this is a little bit of a misnomer. Toxic pollutants were really a negotiated list of pollutants with an environmental group and a consent decree to litigation that were then codified into the Clean Water Act as priority pollutants. So the term toxic pollutant there is really a term of art, not a description. They do have toxic effects, but the last category, non-conventional pollutants, is basically anything that's not a conventional or a toxic pollutant that's on that specific list, but they still have toxic effects. So very important. Non-conventional pollutants doesn't mean that they're not toxic, that they don't have issues. It just means they're not specifically on that toxic list and they're not a conventional pollutant. So things like chlorine, ammonia, nitrogen, phosphorus, emerging contaminants fit in here as well. They're not on that list. So pharmaceuticals, basically anything else that you can think of would be classified as a non-conventional. And last, waters of the U.S. Not going to get into this one too much. And the reason it is because how we teach the course is that if you're a permit writer, you get an application for a permit that you process to write a permit. Once you get an application, someone else has already done the dirty work of deciding whether you discharge to a waters of the U.S., whether it's a navigable water, whether it meets that. There's been a lot of litigation in the past 10 or 15 years over what is a waters of the U.S. So what we tell the permit writers is, luckily, once you get an application, you don't have to worry about that question. Someone's decided that they need to apply, and you just write a permit. One important thing about a waters of the U.S., though, is that groundwater is not a waters of the U.S., but it can be a waters of the state. So the NPDES program does not regulate groundwater itself. However, states can have requirements for discharges into groundwater. Just at the federal level, we do not under the Clean Water Act. One thing that you may have heard about, and not to get too far off into it, but we've had some recent cases about where a point source discharges to a ground into the ground, and that flow ends up in a surface water in a very direct manner. There's a recent Supreme Court case that called it a functional equivalent of a direct discharge. And in that case, we can regulate that point source, but what we're regulating is the discharge that moves through groundwater to the surface water, not the groundwater itself again. We don't regulate groundwater. It's a subtle distinction, but we're regulating that discharge and the pollutants in the discharge, not the groundwater itself. So that Authorization. So under the Clean Water Act, states could apply to be authorized to implement the program. And there's 5 basic components. And these 5 components really reflect, once again, addition of programs to under the MPDS overarching program. So we started with the basic municipal or wastewater treatment plant and industrial permit program, the pre-treatment program, the federal facilities, the general permit program, and the biosolids program are all other components that have been added to the MPDS authorization. And what we see is that states can apply to receive authorization for any of these components or all of them. So it can be a mix and match. They don't have to take authorization. And so this map shows kind of that picture, that we have a number of states that are fully authorized, including all of the programs, including biosolids. Biosolids is probably the program that most states don't have. And you can see that reflected in the next blue, fully authorized. So this is ones that have everything but biosolids. And then partially authorized. And this means that they have some subset of those 5 programs. And in many cases, this means that EPA remains the pre-treatment authority for that state. And then unauthorized states, there's really only 3 states left, some of the US territories and the District of Columbia, where EPA still writes permits. And we are the permitting authority. So you can see this makes it, as Chris mentioned, this can make it challenging. Because when we do an authorization, what the Clean Water Act requires is that the state demonstrate they have legal authority to implement the program. They can adopt regulations that are different than the federal regulations as long as they're consistent with them. It sounds a little bit odd to say that, but what it means is just they have to be able to implement the program in a way that's as stringent as a federal program, but they can go further. They can be slightly different. They can come at techniques from a little bit different way. And that's where we see that every state can have a little bit different approach to the MPDS program. And it makes it challenging for EPA in its oversight role, because we essentially may have, with the 50 states, 50 different ways that the state wants to implement the program. So that's really the overview of kind of where that fits. This is just a list showing the key MPDS regulations. So the Clean Water Act provides the statutory authority, and then EPA adopts regulations. An important point here is that when we adopt a regulation, it has to go through a public notice and comment process. So we put the proposed rule out, we take comments from the public, industry, environmental groups, the public at large, and we have to respond to those comments. They don't necessarily drive what the final rule will look like. It's not like they can say you have to change this. But if they raise a valid point, we have to address it in that response to comments and describe why we're maintaining the rule as we proposed it, or if we're making changes in response to comments. But as you can see, it's a fairly comprehensive list of regulations about the EPA program, state programs, procedures for decision making, water quality standards, effluent limits to some extent, water quality limits. So there's a whole host of regulations that help govern our program that the states have to be consistent with. So any questions at this point? All right, so let's do a quick overview of the pre-treatment program. So the pre-treatment program, as I mentioned, is not technically part of the MPDS program, but it's complementary to it. It addresses indirect dischargers. The regulations are found in 40 CFR Part 403. And this is really for non-domestic industrial sources discharging wastewater to POTWs. So very similar to the program you have. And the purpose of the pretreatment program is to prevent the introduction of pollutants into POTWs, which will interfere with plant operations or pass through untreated, to improve opportunities to recycle and reclaim wastewaters and sludges. So this is really that focus on reuse or beneficial of wastewater, whether for industrial, agricultural uses, or even potentially back as drinking water. And then sludges and how those can be used in agricultural settings or other settings. And then last is to protect POTW workers. We want to make sure that what's put into the collection system that ends up in the wastewater treatment plant doesn't interfere with the workers as well. If we are, making workers sick or, killing them, that's not a good thing at all. And we want to make sure we're very protective of that. So what does the program look like? Well, EPA, once again, was the primary authority. And then as states apply for approval of the pretreatment program, they can get designated as the approval authority or a control authority or industrial users. And as you can see with the arrows here, there can be a different approach in each state about how the program is implemented. So in some states, EPA remains both the approval and control authority and directly issues requirements to industrial users, that the state can become the approval authority and then issue requirements. Also, the POTW can become what's called the control authority. And then the control authority issues requirements to the industrial users. So once again, pretty complicated in some respects, but it's in terms of how many different variations we can have. But the idea is each entity that has a role has to meet the regulatory requirements. And we have, as I said, we have the pretreatment staff online. They teach a 2-day course at minimum on this, their 101 course, and they have advanced courses. So the pretreatment program, again, is a pretty complex program, just like the MPDS program. There's a lot to it. So pretreatment standards, there's 3 main categories. There's general and specific prohibitions, categorical standards, and local pretreatment standards. I'm going to cover the general and specific prohibitions here, and I'm going to cover the categorical standards when we get to effluent limitation guidelines. They're not part of the effluent limitation guidelines, but they're proposed with the effluent limitation guidelines, and I'll talk about that more when we get to the technology limits. And then local pretreatment standards. And an important point here is that these standards can be expressed on the industrial users as numeric limits, narrative prohibitions or narrative limits, and best management practices. And best management practices are those things where we can assign a numeric threshold for a discharge, but we can say things like you need to sweep up better, prevent material from getting into a drain that goes to the wastewater treatment plant. So things to prevent or reduce the level of pollutant that ends up in the wastewater by implementing a best management practice at the facility. One key thing here is that these standards are self-implementing. So industrial users discharging into a POTW have to comply with these standards, even if they don't have kind of a direct permit in place. Now, the way that it works typically, though, in terms of determining compliance or implementation by the industrial users is that the POTW permit or the control authority interacts with the industrial user and makes sure that they're meeting the requirements. And hopefully I'm not expressing that too badly. As I mentioned, I'm not the expert on pretreatment, but to keep this rolling forward, it was decided I'd just keep presenting versus trying to switch back and forth. But if you have questions, feel free as we go forward. So general prohibitions. A non-domestic discharger may not introduce into a POTW any pollutants which cause pass-through or interference. And so this is just that general prohibition, a narrative requirement that gives the regulatory authority to the control authority to address industrial user discharges, to put in requirements to treat or prohibit the discharge of pollutants into the POTW. We have some specific prohibitions that are listed out, and these are pretty common sense. When you look at these, pollutants which create a fire or explosion hazard, cause corrosive structural damage to the POTW or its collection system, that would cause obstruction or result in interference, heat that will inhibit biological activity and reduce the efficacy of treatment, pollutants which result in the presence of toxic gases, vapors, or fumes. And we don't want people just dumping into the system, so trucked or hauled pollutants except at discharge points designated by the POTW. So these are in our regulations, and industrial users have to comply with them. So here are some examples of what can happen. This was in Louisville, Kentucky. A soybean processor released hexane into the collection system, and it was ignited and blew up 3 miles of collection system under the street. Amazingly, no one was killed in this this event, but as you can see, pretty substantial damage to the collection system. And the second photo shows, you know, what can happen when we have buildup in a collection pipe from someone putting substances that can. So why the pretreatment program is very important in terms of protecting the POTW, you know, beyond just the pass-through of pollutants or interference at the plant itself. So local pretreatment standards are required for all approved pretreatment programs. These are locally developed but federally enforceable. And the way this works is that the POTW looks at all of its industrial users and the pollutants that they are proposing to discharge and looks at water quality criteria, what MPDS permit limits are or might be, and other standards that may apply, and comes up with what is the allowable amount of that pollutant that can be discharged into the system. And then they look at what comes from what are termed non-industrial users, but there may still be other inputs of that pollutant into the system. So from domestic households, there might be additional sources of the pollutant, but we don't regulate domestic households under the pretreatment program. And then often there's a safety factor. And so the end result is that they come up with an allowable amount of that pollutant that can come from industrial users, and then they allocate it to the users under these local limits. They can be chemical specific, best management practices, prohibitions, case-by-case discharge limits. But this is really how we get to this. And the important thing here, I think a difference between the pretreatment program and your program is that this is for any pollutant that would be discharged by an industrial user. It's not a specific list. If it causes an issue in the treatment plant or in the water body after discharge from the POTW, it can be addressed through the local pretreatment standards. So emerging contaminants, pharmaceuticals. Yeah.
Sean, this is Phyllis. I'm just wondering if you could talk briefly about how that's enforced and how it's implemented.
Okay, for that, I think Jan is on the line. Jan, do you mind taking that one?
Hi. Generally speaking, after the local municipal group, usually it's a municipality, a city, studies their treatment works and its process efficiencies and its industries, it already, part of its requirement is that it has its own suite of legal abilities, its own set of regulations, and they then incorporate that into a permit that they issue to the industries that discharge into them. So essentially, the municipality becomes another permitting agency. And not only do they issue the permits with limits on what can be discharged, they will go out and inspect them. They will go out and take enforcement action if there's a violation. It's another little mini permitting program.
And you mentioned that that's on industrial users. Is a hospital, a complex, considered an industrial user?
Yes. Essentially anything that is not a residence. And we don't federally have a definition for the word commercial. So as long as you're not a residence, you're in industry.
Does that mean that
there are certain categories, as Sean was describing, where EPA has studied the facilities in the sector and prescribed specific standards to meet. And then ones like hospitals, for those that discharge to the local municipality treatment works, there aren't the national standards for the hospital. So then the municipality determines if they are ones that they have to issue a special permit to. Many of them do, many of them don't. Typically, where a municipality looks at the hospital, there's multiple levels there, and I don't want to belabor and get Sean off track on his time management, but We have another set of regulations out of our hazardous waste management group that says that healthcare facilities, which includes everything from a doctor's office to a veterinarian office to a pharmacy to a hospital, cannot flush the waste drugs down the sewer system. But then we also know that a hospital frequently has a food service group, and that has its own challenge of fat, soil, and greases that could clog the lines. So often a hospital is looked almost like its own little small community that has a whole suite of different controls that the municipality may need to look at it and sort of like separate out the little different types of discharges that they would have.
Okay, well, thank you very much. I see a question in the chat. What do the municipality monitor when they enforce the industrial discharge of the pharmaceutical industry? Do they monitor CECs?
For the pharmaceutical industry itself, that the manufacturers, that is one of those industries where EPA has developed a sector-specific set of standards that apply whether it's discharging to a stream or to a municipal treatment works. And a lot of it is more in the solvents end. There's 4 different categories of based on the process that the drug is developed, whether it's a I lost the words now on the different subparts. And so it depends on which type of process the pharmaceutical group is using to do that manufacturing. A lot of it's on solvents. A lot of it is on best management practices so that they do recycle streams, because essentially if they discharge drugs down the drain to a river or to the municipality, they're losing their own raw material, and they recognize they don't want to do that. And a lot of it is actually more on some of the biological indicators, like biological oxygen demand, because it really is doing that whole thing on assessing the process efficiency to remove their own products.
Okay, well, I don't want to belabor the point, but if you could possibly put in the chat some references as to where we might find those materials on the EPA website, or in whatever resources you could, that would be very helpful. Thank you very much, and sorry to interrupt you.
No worries. Thanks, Jan. That was great. This is why I wanted Jan on, because she can speak the terminology and know exactly what's going on. Pretreatment is a very specialized field, and we're lucky to have Jan, who's had a long history in the program. So how do pretreatment and MPDS interact? Well, the way that it works is the POTW, or wastewater treatment plant permits, have requirements to implement a pretreatment program. So these are kind of narrative requirements that go into the permit. They have to show that they have adequate legal authority, that they meet all of these different requirements, that they have that compliance monitoring activity. It doesn't specify what compliance monitoring they have to do, but they have to have a program that implements it. And that's how this works. Now, in practice, a lot of times these are not well described in a POTW permit. Sometimes they're done just by reference to the regulation that requires them to do so. It's something that Jan and her team are working on with MPDS permit writers to ensure that POTWs have a better description of what is required when they have a pretreatment program that they're required to implement. But this is really how the pretreatment program and the MPDS program interact. These POTW permits should have these requirements in them to require consistent implementation of the pretreatment program on industrial users. But just to be clear, we don't put the local limits in the POTW permit that are applicable to industrial users. That's all that separate mini program that Jan was talking about, where the POTW has its own kind of permits that it issues to those industrial users. All right, so moving on, I think we're doing okay on time, but I may have to pick it up a little bit, so let me launch into this. So applying for an MPDS permit. Well, we have two kinds of permits that are issued. Individual permits, and so this is where a facility submits an individual permit application, the agency processes it, comes up with an appropriate permit, and issues it specific to that facility. We have roughly 50,000 of these. As Chris mentioned, the number fluctuates of what we have completely, but the idea is that it's about 50 to 60,000 of these nationwide. So there's not it's a lot of facilities, but relative to the MPDS universe, it's not a lot, but these are also the significant facilities being discharged. The second category we have are general permits. And general permits are really appropriate where we have multiple similar sources within the same geographic area that require permit coverage. They have similar discharges and require the same or similar permit conditions. So this is just an efficient way to permit a lot of facilities that discharge the same wastewater without having to go through the burden of issuing individual permits to each of them. So in this case, the permitting authority develops that general permit, proposes it, takes comment, finalizes the permit, and then facilities submit what's called a notice of intent for coverage. And notice of intent gives some basic information about their operations and that they meet the conditions to receive coverage under the general permit, and then they're covered. So things like stormwater, things like the pesticide application, vessels were covered under this, where we have very similar activities, widespread, where it's an efficient way to issue permits. And as I mentioned, magnitude-wise, 500,000-ish. Chris mentioned up to 750. It fluctuates because who is covered by, say, the stormwater permits? We have a construction general permit. That number fluctuates up and down depending upon how much construction is happening. Each construction site has to apply for coverage, and then when they're finished with construction, they terminate their coverage under that permit. An important thing with all permits, though, is that they're limited to statute to a term of 5 years. They can be shorter, but no permit can be issued for a term of more than 5 years. So what does a permit look like? Real quickly, so we have effluent limitations, technology-based and water quality-based. For non-POTWs, it's those effluent limitation guidelines and what are called the case-by-case limitations. And for POTWs, it's secondary treatment or equivalent to secondary treatment. And we'll cover these in the next section. Just wanted to give an overview of what a permit looks like. Monitoring and reporting conditions. And then what we term special conditions. Studies that aren't related to a limit, but are important to help characterize the activities at the facility and the discharges that are occurring so that we have more information or better information about the potential impact. Those best management practices, the narrative kind of requirements to prevent or reduce pollution, and compliance schedules. Compliance schedules, often when limits are put into a permit, the permittee can't immediately comply. And so in certain cases, we can give them time to implement controls to meet the limit. And then special conditions for POTWs, we have the pretreatment requirements, municipal sewage sludge, and what are called combined sewer overflows that can be in those POTW permits. And then last, we have what are called standard conditions. And these are in the MPDS regulations. They're required to go into every permit. And they really cover a whole host of things, but it's to ensure that we get consistent monitoring and reporting and an implementation of limits and permits. So just kind of a overarching requirements that go into the permit that make sure we get information consistently from permittees. So as I mentioned, we have individual application forms. And the concept to take here is that we've created different forms for different industry types, different types of facilities to make sure that we get the right information from them to craft permits. And so each form is specialized to what we know about that type of facility and the type of information we need to assess their potential for discharges that cause an environmental impact. And below at the bottom is our link to the application forms for more information if you want to look at it later. I wanted to highlight some requirements of some specific application requirements. So Form 2A applies to those publicly owned treatment works, POTW, sorry if I didn't define that earlier, but wastewater treatment plants. And just to highlight here, the application requires them to identify significant industrial users. It requires them to identify when they have outfalls to things other than waters of the US. So even though we don't regulate those discharges, we want to know what the fate of wastewater generated at the facility is to make sure that it's not ultimately ending up in a surface water, and also just to be clear to the public where it's going if it's not being discharged into the waters of the US. And so that also includes underground injection. So we have a whole underground injection program that EPA runs. So if they're doing underground injection, then that's covered by that program. But we want to know that they're sending their wastewater to that program. Form 2S is about sewage sludge management and disposal practices. So POTWs have to submit that. And we also have sewage sludge treatment facilities or privately owned treatment works that also generate sewage sludge who have to submit those forms. And then Form 2C for existing industrial dischargers requires, once again, that they report final disposal of solid or liquid waste other than by discharge. So if they're discharging to a POTW, they're required to identify that. If they're disposing of it in some other manner, they're required to tell us where they're sending that waste. So once again, we can't regulate it, but we know if we need to identify for that facility if there's other controls that are necessary. All right, so technology-based effluent limitations. So just a quick, this is how technology and water quality interact. They complement each other. But what we start with is we develop T-bells derived from those technology standards for all applicable pollutants of concern. And then once we have T-bells, we develop WQ bells for all pollutants that are discharged. And it's primarily, but where a T-bell is not adequate to meet water quality standards, we have to implement a WQ bell. So if we don't have a T-bell for a specific pollutant, then we definitely have to do a water quality-based effluent limit. If we have a T-bell, then we assess whether we need to include a WQ bell in the permit. Is that T-bell stringent enough to meet water quality standards, or do we need a more stringent limit? It looks like we had a question come in, maybe. Let me see if my chat will load here. So we'll get to, that may be with the application, but we'll cover it in monitoring. But real quick, with the application, that's self-collected and reported data. We require them usually with the application to submit the original lab reports, which shows any quality assurance and QA procedures on the collection of the sample, analysis by the lab, and to validate that the data reflects this. But we'll talk about it when we get to monitoring and reporting. We require facilities to use specific methods, and they have to follow those methods. And those methods are what we rely upon to ensure that kind of self-collected data is representative of the discharge. Another important point, I guess, is if someone falsifies data in that way, it actually is a criminal act, and criminal enforcement under the act is much more severe than civil enforcement. We have two types of enforcement. I'm not going to get into enforcement too much today because it's really past the permit being written, but falsifying data is a very significant issue. Or not significant in that, but has harsh repercussions is the best way to say it, I guess. All right, so for publicly owned treatment works, we have secondary treatment standards, and these are really focused on the pollutants that are associated with treating domestic sewage. So BOD, total suspended solids, a % removal. And this is basically to ensure that we're getting effective treatment, that we're not just diluting the effluent in the collection system. So infiltration into the collection system. We want to make sure that the collection system is not having excessive I&I that would dilute the effluent to where they're meeting the standard without actually doing treatment. So we have a % removal. We measure at the headworks and then at the final, and they have to have 85% removal of BOD5 and TSS regardless of what the limits are that they have to meet. And then we have pH requirements. And these limits are expressed as average weekly and average monthly limits, unless impracticable. And the Clean Water Act and the regulations do allow for less stringent requirements for certain facilities. And it's really based on when EPA developed these, what we call secondary treatment standards, that they recognize that certain facilities may not be able to achieve them. So they gave some flexibility to states to reduce them on a case-by-case basis. So for non-POTWs, what are those controls? So these are some of what Mary Ellen covered with the BAT discussion, but we need to go a little bit further. So for existing sources, there's what's called BPT, or Best Practicable Control Technology, Best Conventional Pollutant Control Technology, BCT, and then that BAT, Best Available Pollutant Technology, Economically Achievable. And these are basically increasing levels of control. So BPT is a cost-benefit test. It's basically what technology is widely available to the industry already. BCT and BAT are a higher economic test. And we'll talk about these a little bit more at the end of the session when I get to case by case. But important here is that when we issue an ELG and we develop these standards, we also issue those pre-treatment standards. And the standard for pretreatment is the same as BAT. So when the pretreatment standards are proposed, they follow the same type of analysis as we do for BAT. So it's economic achievability. And then we have those new source performance standards. Not going to get too far off into it because new source can be a confusing topic. But basically, a new source is any facility who is constructed after a effluent limitation guideline is published. So it's not anything about the facility itself, a date and time. It's about when an effluent limitation guideline is finalized. If you're constructed after it, you're considered a new source because you had fair notice that you're going to be subject to these more stringent controls. And new sources really reflect the idea of building a facility from the ground up. You have the chance to include the most stringent treatment technology. You can design the facility for the piping, for the energy demands, for everything that would come into play that an existing facility retrofitting a technology in imposes additional costs or restraints. And this chart, I think, just helps describe how all those technologies work together for the non-POTWs. So we have the direct dischargers and indirect dischargers, the new sources and existing sources, and the different levels of control. And which pollutants they address. So that's important here. You know, BPT addresses all three categories of pollutants. BAT only covers non-conventional and priority pollutants, those toxics, because BCT is a companion for conventional. And the new source performance standards covers all three again. For those indirect dischargers, we only look at non-conventional pollutants and priority pollutants because the conventional pollutants are addressed by the treatment train at a POTW. So here are all of the industry categories. Don't try and read them, but just to give you the idea, there's 50 plus industry categories where EPA has developed those standards for BPT, BAT, and pretreatment and new sources. And important here is that each of these categories may have many subcategories. So for instance, battery manufacturing covers all of the different types of batteries that you could manufacture: lithium, lead, cadmium. There's subcategories under these. So the scope is relatively comprehensive. And EPA is required, I think it's every 2 years, to provide an update to the public on which effluent limitation guidelines they're proposing to revise, or if they're developing new effluent limitation guidelines for a new industry category. And this is really to provide the public a chance to comment on whether they believe there's new pollutants being discharged by an industry, a new process that wasn't adequately addressed, or a new industry that needs regulations. So that plan goes out for public comment, and the public has a chance to weigh in on whether EPA should be developing more effluent limitation guidelines.
One question about the BATs. If additional processes or new technologies have been introduced since those original BATs have been developed. Does the EPA regularly update those things?
Well, that's a great question. Updating effluent limitation guidelines is a laborious process, especially in kind of the current environment where we have a lot more interest by industry, a lot more information, I guess is some way to put it, so that's where that plan comes into place, that people can propose that we address new process wastewaters, changes in the industry, but many of these are old. Many of these have not been updated well. But in a second, I'll get to how we address new processes or pollutants that were not addressed by the existing effluent limitation guidelines. So there is a procedure in place. It's one that is a little bit more burdensome to the permitting authority, but we do have a way to address it when there's a concern. But the goal always is that we're looking to update these ELGs to address those new processes or new industries. So here's a slide I just wanted to cover for those categorical pretreatment standards. So as I mentioned, they're issued with the ELG, but they're not part of the limitations subject to the NPDES program. But 37 of the 59 ELGs have categorical pretreatment standards. Here's some of the different categories where we have it. As you pointed out, hospitals have pretreatment requirements. And real quick, I just wanted to show you this website because it's something that just came out this year. It's incredibly helpful. It's on EPA's webpage, and you'll have that link when you get the presentation. But it's a database that our Office of Science and Technology, who develops the effluent limitation guidelines, pulled together. And so, for instance, we can search for the pollutant lead, or we can search by point source categories, treatment technology, or other factors. But if we look up lead, what we find is it will tell us all of the effluent limitation guidelines where there's limitations on the discharge of lead, and tells you the range of pollutant limitations that are in each industry. And that's a good point, that each industry may actually end up with different limits based upon consideration of the same technologies, because there may be different interferences or different economic achievability. So each industry is assessed uniquely. So if we look at one of the limitations, what you'll see is here, for lead, we have BPT, BAT, BCT, the news source, the pretreatment standards. So this is a great tool for quickly seeing for an industry category what the requirements are on the different processes. And then what's nice as well is you can also see when EPA does its assessment for developing limits, it looks at the available treatments for that processed wastewater and picks a model technology. And then that model technology, they determine what's called a long-term average of effluent data would be after treatment for that industry as a whole. And then they use a statistical process to translate that long-term average of the data So very helpful as we go through it. But this database is a great tool for really accessing the effluent limitation guidelines and what pollutants they regulate and how they do it. So just wanted to share that quickly. And so effluent limitation guidelines, the limits can be expressed as production or flow based. So sometimes it's milligrams per kilogram of lead used in a process. That's one from that lead battery. They can also be expressed as flow based, where it's a milligram per liter, and you look at the flow from the facility to determine what is the allowable discharge. The regulations require that they be expressed as mass limits unless specifically authorized otherwise. And what we see sometimes is that there's a catch-all category of miscellaneous wastewaters. So we know that wastewaters are combined at a facility, and we can have a miscellaneous wastewater effluent limitation. So we can address a lot of kind of smaller discharges under one processed water waste stream. So here's what I was talking about. So we have the effluent limitation guidelines, which are those published guidelines, But the Clean Water Act and our regulations also give us the authority to do case-by-case limits. So where the effluent limitation guideline did not apply to a new process or to a pollutant that was not identified in the development documents for the ELG, we can develop case-by-case technology limits. It's basically doing a mini effluent limitation guideline development. So we consider the same factors that are considered by EPA in developing the ELG. We use the same economic cost tests, BPT, BCT, and BAT, but it's done for that individual facility. And so it's burdensome on the permit writer to do it. So I'm not going to say that they're a common thing that happens, because you're asking a permit writer to become an engineer, an economist, and everything else in between as they develop these. But where there is an adverse environmental impact, often states will put the effort in to do these. One thing you'll find, and Rob Wood and Mary Ellen referenced it, there's a lot of pollutants that have been reduced in terms of the amount being discharged by the effluent limitation guideline program. But remember, the backstop to this, and we're going to get into it next, is the water quality based effluent limits. And often water quality based effluent limits are more stringent than the technology limits. And so even if you calculated case by case limits, you may end up with a more stringent WQ-BEL, and that's the limit that's going to go into our permit.
Sean, can you just talk just briefly about the BTT, the BCT, and the BAT in terms of the different analyses that are done?
Well, we look at the same criteria. The difference really is what the economic test is. So for BPT is the cost to implement the control, is it a cost? It's a cost benefit test. Do the benefits justify those costs? And it's kind of the base level of control. And the rule of thumb that I've usually heard with this one is that about 80% of the facilities in the industry already employ that level of technology. It's commonly available, widely used. You're really just getting the last people who haven't adopted that level of control. BCT is about comparison to POTW treatment costs. So the idea is that you could discharge this wastewater to a POTW, it could be effectively treated. Is your cost greater than what it would be to cost to treat it at a POTW? And then the BAT is kind of that the technology pushing, limitation pushing. So this is economic achievability. So when we do an effluent limitation guideline, this is economic achievability of the industry as a whole. So when we do that analysis, it's not for an individual facility. We look at the industry as a whole and say, can the industry bear this? And that may mean that some poor performing or low revenue facilities might close. It might be too expensive for them to implement the technology. And at a limited level, that's okay when we're developing a national guideline. On the case by case, it would be looking at the plant or firm level as to could that firm or the plant itself, if it's a multi-plant firm, could that plant afford to install the treatment technology? Is it economically achievable without putting them out of business? But for BAT, it really is intended to be technology forcing. It can be only one facility has shown that it's commercially viable to operate with that technology. It can even be a bench scale technology that shows promise. If it's a new technology, it hasn't been installed yet, but EPA believes that it's economically achievable, it can be required at the facilities across the entire industry category. Is that helpful?
Yeah, that's
Okay.
great. When you mean the technology forcing, you don't mean a specific technology, you mean the ability to achieve the results that this new technology can achieve.
Right. So we identify model technologies, we determine the performance standard, that long-term average that's attainable if a facility used that technology, and we set the performance standard, but they can meet that standard using that technology, any other technology, or any combination of technologies. And what we find is that facilities and treatment system manufacturers find a more efficient, better way to meet that performance standard. And then for when we reassess the effluent limitation guideline, we now have a new model technology, something that does it cheaper or better. And you may not see a revision of that effluent limitation guideline specifically, but other new guidelines will then use that new technology as it becomes available to other industries. So it's kind of an iterative process. And then what you find too is that if a technology is truly cheaper to implement, over time, facilities transition to it. They want to operate the cheapest, most efficient, easiest technology. Okay, so in interest of time, I do need to keep cruising on, so I apologize, but if we have time at the end, we can pick up more questions, and always happy to take questions and follow up. So water quality based effluent limits. So why do we need them? Well, number one, the statute requires it. It recognized that technology limits might not achieve the level of protection needed once we didn't meet that no discharge standard. You know, if we'd met no discharge, we would have been in a different world. But it was recognized that that was not going to lead to complete elimination, so we needed to have effluent limitations to meet water quality standards. So we have kind of two categories of waters not attaining water quality standards. And the goal there is to prevent further degradation and through the NPDES permit to implement corrective actions to restore the waters. And then for waters that are attaining the water quality standards, we want to protect the beneficial uses and prevent excursions of the water quality standard. And if we have a higher quality of water, we want to protect that. We want to maintain that higher quality. We don't want to say, oh, you can degrade it down to the lowest level. So we have provisions in place to prevent that. So the three categories are components of water quality standards, and Randy went over this, so I'm going to do this one relatively quick. Designated uses. These are things like that primary contact, secondary contact recreation, public water supply, protection of aquatic life. To protect those designated uses, we implement water quality criteria. And these are the numeric or narrative criterion or thresholds that protect those uses. One of the things that we do use is what's called whole effluent toxicity. And this is an evaluation of the effluent to see if it causes toxic effects, typically to aquatic life. And it's really to assess, are we having additive or, sorry, my mind just went blank on the term, but basically cumulative effects in an effluent. So we know individual pollutants have toxic effects, and when we put them all together in the effluent, do we have a greater level of toxicity? And then we have the narrative, and these are typically called free from. So free from toxics and toxic amounts, free from nuisance conditions, free from color or odor. But a very common thing that's included in permits to address kind of narrative requirements. And then the anti-degradation policy. And this is really protecting the existing quality of water, not letting it be degraded further without some kind of analysis by the permitting authority to say that that degradation is necessary. And then the last one is general policies. And these really cover things like mixing zones, because we discharge into flowing waters or lakes, whether you can have mixing zones or not. Variances from water quality standards, so short-term relief. I noticed that you have a similar component in your standards where facilities can get a short-term relief from the more stringent standard. Compliance schedules, as I mentioned, when we put a new limit in the permit, time to install technology to achieve that limit. Sometimes the water quality standard will specify critical conditions or low flows. So low flows in flowing streams, what is the low flow that we're trying to protect? Because obviously in a stream you can have very low flows, very high flows, and we typically are expressing a criterion that it protects it at very low flows. So when the pollutant would be most concentrated in the water body. And then ambient concentrations, sometimes these are specified to give direction to the permitting authority on what is the appropriate background concentration to use for a pollutant in a specific water body. Sometimes we don't have data readily available and the state wants to use a default number. Water quality criteria for aquatic life have three components: a magnitude, so the concentration of concern, a duration, the time period that it's exposed. So for an acute criterion, this may be a 1 hour exposure. For a chronic criterion, it's a 4-day exposure up to a 30-day exposure typically. And then frequency, how often they can be exposed to that concentration and duration. Often what I've seen is that it's once every 3 years. So the idea is if they're exposed to this situation once every 3 years, that aquatic community will be able to recover to its original status. If it happens more frequently, then you would see degradation of the aquatic life and a reduction in the community. So that frequency is an important component. So as I mentioned, those critical conditions. So when we look at developing our water quality-based effluent limits, we often follow using critical conditions. So looking at the worst case example, because if we put limits in the permit that that protect the worst case scenario, then at all other times of discharge, they are more stringent or are meeting the water quality criterion without any issues at all. And so we put in the most stringent conditions, and then at other times when there's higher flows in the water body or lower flows in effluent or lower pollutant concentrations, we know that they're protective of those water quality standards in the criterion. So for effluent, we have the effluent flow, and we typically use the maximum observed or design flow from the facility. Effluent pollutant concentrations, this is one that we look at the observed data, but we also use a statistical process to estimate what might be the highest pollutant concentration we would ever see. Receiving water conditions, receiving water flow, common for our streams, and we use what's called a 7Q10 flow. So the lowest 7-day average flow that would be experienced over a 10-year period. And so that's a very low flow. Background pollutant concentrations, so what is the assimilative capacity? Often this is assumed to be 0. It's not a great assumption, but if we don't have data, often it's hard to pick a number that's defensible. So the default is often to 0. Hardness, some metal criteria rely upon hardness to demonstrate the toxicity, and other receiving water characteristics, such as temperature, pH, reaction rates. All right, so I am going to have to speed up a little bit because I know we're getting close to end of time here. I apologize, but we had some good questions. So often we use a simple mass balance equation, makes life simple and easy, and many of the permit programs use this. So essentially what's upstream from the discharge equals what goes downstream, and we use that to calculate our limits. We do have a process called reasonable potential analysis, and this basically determines whether we need to include a limit or not. And this is kind of a conservative estimation of what the highest discharge of pollutant would be from a facility, and does that exceed the criterion when we look at the receiving water concentration. We have to account for the variability of the pollutant or pollutant parameter, and this is where we use statistics to help us. So when we're determining that critical value, the maximum effluent concentration, we have limited data often. So we may only have 6 data points. We determine that typically for effluent data, a log normal distribution best fits the data. But when we only have 6 data points, we don't know if they look like this or they look like this. So we use statistics to help us out. EPA looked at a lot of effluent data sets, large data sets, and came up with a statistical approach that accounts for how to translate small data sets into a maximum effluent concentration. And we use the coefficient of variation, so the variation in the data, and the long-term average to describe this log normal distribution, and then use that to implement the statistical approach. So in this case, we want to find that highest concentration or estimate it, and we use a CV and LTA to get there. So if we were just collecting data, to be confident that we were out at this 99th percentile, we'd have to collect 330 data points. We often don't have that data. With an application, we may only get 1 data point. So what EPA did in looking at all of those large data sets was to come up with a ratio or a multiplier between the 99th percentile and lower percentiles. And we have these in an equation and a table. So when we have small data sets, we can multiply by a factor to estimate what the 99th percentile would be. And as we get more data, that multiplier gets smaller and smaller. So you can see at 50 data points, which is essentially monthly sampling over a 5-year permit term, we get to a very small multiplier. So once we determine reasonable potential, we compare that effluent quality to the criterion. If we have reasonable potential, we develop what's called a waste load allocation. And this is basically looking at the criterion and the flow downstream. We use that same mass balance equation, and we calculate what the maximum effluent discharge could be and still meet that criterion. And that's what's called the waste load allocation. A waste load allocation, though, is not a water quality based effluent limit because the duration of the waste load allocation is based on the duration of the criteria. So it's a 1-hour average or a 4-day average, and we're turning that into a daily average or a monthly average. So we have to use statistics to translate the waste load allocation to a final limit. So what do? Well, we know our waste load allocations for acute and chronic criterion, and we have our data. And we know the long-term average of our existing data. What we want to do is decide what LTA is necessary so that the data would never exceed those criterion. So that's what we're doing. We're basically taking our waste load allocation and translating it into a long-term average that would be protective of that. So we have our waste load allocation, and we adjust our log normal distribution so that the waste load allocation falls at the 99th percentile. Then we can describe that with our LTA and CV. Then we take that LTA and we use statistics to translate it into the limits. Because the LTA takes out that duration factor. It basically turns it into a long-term average, a multi-year average that we can compare to for the different criteria. And then we take the lowest LTA and translate that into the limits. And so, take that lowest LTA, we do our log normal distribution, and our maximum daily limit becomes at 99th percentile. For pollutants that aren't toxics, the TSD process does not work that well. So for things like pH, pathogens, nutrients, and temperature, distribution because they don't follow that type of distribution. So we have different approaches for these different pollutants and that lead to limits that are protective in permits. So once we have our final effluent limits, we compare the T-bells and WQ bells. Then we do something called anti-backsliding. So we compare final limits in the permit to limits in the previous permit. And we can't backslide unless we meet certain requirements. So if someone's achieved a level of treatment or effluent quality in a previous permit, we don't want to say you can discharge more. They've demonstrated they can achieve a more protective effluent level, and we want them to maintain that. And this is where we do the anti-degradation review that's required in the water quality standards. So we look at whether final limits allow new or increased pollutant loads. And if they do, we have to go through an anti-degradation process. And it's basically saying, is it necessary and important? And there's 2 types of analysis that are done. And so this helps us ensure that if we're allowing a new mass loading into the water body, that it has been evaluated and the public has a chance to weigh in. Then special conditions are used in NPS permits, as I mentioned, to address those unique situations, to incorporate special studies, more monitoring, the pre-treatment programs, sewage sludge requirements. So once again, very straightforward to some extent, but this is where the permit writer has the most flexibility for how they incorporate it. Just wanted to cover the biosolids. It's covered under our Part 503 requirements. So we do have requirements for sewage sludge use for incineration, land application, or surface disposal. I really don't have time to go into it today, unfortunately, but we do have a whole website, and I'm sure it's something that we can follow up on if there's more interest in how we regulate the sewage sludge itself. And last, the list of standard conditions. So these are those conditions that I mentioned that basically standardize what a permittee has to report to the permitting authority across the entire NPDES program. So there's a duty to comply with the limits, a duty to reapply at the 5-year period, that they mitigate any adverse impacts, they exercise proper O&M. So you can see kind of the theme there. It's just a standard approach to make sure that the permittee is doing what they said they would do when they applied for a permit, and that we're getting the appropriate information from the facility to determine compliance with the permit conditions. And then monitoring and reporting. Monitoring has to be representative of the monitored activity. So we have to have the type of monitoring, grab or composite sampling. If it's a monthly limit, we want to make sure that we're getting the appropriate sampling to determine compliance. A daily limit, same thing. As a facility collects data over multiple permit terms, sometimes the monitoring frequency is reduced because they've demonstrated that they're consistently meeting the limits. And so we have some confidence that if we reduce the monitoring, that they're still going to comply with their limit requirements. So we do have that component that often comes into play when we have a long-term discharger. With monitoring, I mentioned I did want to get to this slide. I know we're pushing our time, Sally, so if I'm out of time, tell me when I'm out of time. But we do require facilities to use what are called the Part 136 methods. And I noticed in your regulations, you have the standard wastewater methods referenced, the book. This is essentially the equivalent to that. And we require permittees to use a Part 136 method if it's available. And real quick, I just wanted to show this site because it is helpful, the National Environmental Methods Index site. You can search for any pollutant, and it gives you all of the test methods within the US that are available from many different organizations. EPA ones are listed here as well. And when you look at them, the nice thing is that it tells you all about the method, where you can get more information, and it also gives you an estimate of the cost to require the monitoring. And this is an important tool to help us understand what burden we're putting a permittee under when we require monitoring in a permit and how often we require the monitoring. A recent change that happened was EPA specified that a method has to be sufficiently sensitive. And this was really in response to, we were seeing sometimes a permittee try and use a method that didn't demonstrate compliance with the limit. And so this requires them to use a sufficiently sensitive method where the minimum level is at or below the limit established in the permit, or it's the lowest minimum level of any approved analytical method. So sometimes the limit may be below what we can quantify, but we require them to use the most sensitive method. So a real quick, just a description of this. Here's our effluent limit. Here's our method detection limit. Here's our minimum level. This is great. It's lower than the effluent limit. We know that this method will demonstrate compliance. But sometimes the limit is much lower. And in this case, the permit writer has to specify in the permit how we determine compliance. An important point is we always put the limit in the permit, even if it can't be quantified. So the limit goes in as 0.2, and then the permit says compliance with this limit is demonstrated by being below the minimum level. And the state can choose what level they want to set to demonstrate compliance. But this is the way that we approach it. The limit always goes into the permit, and then they have to use a sufficiently sensitive method, and the permit demonstrates what that is when it's not below the effluent limit value. Looks like we have a quick question. When do we choose composite and not grab sampling? It depends upon the limit and the pollutant itself. Obviously, if we're going to do composite sampling, it has to be a pollutant that doesn't degrade, so that if we composite it, we're getting a true representation. And there's many different kinds of composite sampling. There can be flow weighted, there can be just interval. So it's really looking at the pollutant and the discharge and determining what is the most representative type of monitoring. So hopefully that helps, but it really is depending upon what we're trying to look at and how the facility operates as to which sampling method is appropriate. And I apologize for
Sean.
yeah,
We're at
our
maybe
time.
1 minute, and
Okay.
I wish you could go on, but all good things.
Yeah, so I'll just cover this last slide, and then the last one was administrative process, which we don't really need to run through because it's not as applicable. And sorry, we had some good questions, and this, as I said, knew was going to be a lot of information. But reporting, those standard conditions help require what has to be reported, and the permit establishes more specific requirements. If a facility monitors more frequently than required using approved methods, they have to report that data. So they can't kind of do their own internal testing and then say, oh, we're only going to give you what's required. They have to give us that information. And typically we get reports monthly, but the permit can establish a less frequent or more frequent reporting basis. And one of the big changes was in 2015, we started phasing in electronic reporting. So before that, facilities could submit paper reports to the states. The states had to upload them into our system. It was just a burdensome process to get data into a database. So we transitioned to an electronic reporting rule where permittees will be required to submit their analyses electronically, and it'll just streamline compliance efforts and entry of the information into an accessible database. So administrative process, I'm going to just go ahead and skim through, and we'll get to the last slide where we give you the information. The important thing about the administrative process is just that it is a chance for EPA and the authorized states and the public to interact and determine that the limits in the permit and the conditions in the permit meet the Clean Water Act requirements. I mean, that really is the summary of it. Every state uses a little bit different process. EPA regions sometimes use a little bit different process. But the important thing is that the public is given a chance to interact and provide feedback about the discharges that will affect their the waters that they interact with. So last slide just shows our NPDES Permit Writers Manual is available online. It basically gives you the in-depth discussion of everything that I just went over. We have recorded Permit Writers course training modules that you can view at your leisure. And I included the link for the National Pretreatment Program. So apologize for going a little long, but hopefully it was worth it. And Sally, turn it back over to you.
All right. Well, thank you so much, Sean, for trying to pull all that information. I think we all realize that this limited amount of time is just, you know, what the information we can provide, but the permitting program is very complex, and this kind of training, if you will, could last for months, and it's just a complicated topic. But thank you so much, Sean, for your excellent presentation, and thanks to all of the participants today. And we will, if you have any additional questions, please feel free to send them forward, and we'll try to address them as we go on with the webinar series. Our next webinar is going to be on December the 9th, and it's going to cover some new concepts and innovations in water quality management, in particular concepts around integrated planning and water quality and watershed management and permitting. So we look forward to seeing you at that next date. Thanks again to Phyllis for her excellent moderation here, and also my colleague Maria Lopez Carbo for her support as we've been going through. Thank you all very much, and thanks to all of the EPA staff that participated today and tried to answer questions and provide more information. Thank you.
Thanks, Jan, and thanks, Sean. Really well done.
Thank you.
Thank you very much.
Thank you all.
very much.
Thank you.
Okay,
Thank you.
Uh-huh.